Hello, this is Alex Jenkins.
Hello. And this is Cody Heinley. Today we're going to be making some Betty Crocker cookie mix. Sugar cookies to be precise.
And we also have to include an egg and 1 stick of butter.
Yeah, that's about it. Okay,
Next part.
yeah.
So with all the materials, we have chemical names for what's in here. We have salt that's included in here, baking soda, and salt's chemical name is sodium chloride. And then baking soda's chemical name is called sodium hydrogen chlorate. Carbonate. This butter right here is changing from a solid to more of a liquidy state of matter as we speak right now, from in this temperature right here to room temperature, which is much warmer, so it'd be exothermic. We're going to take this piece of butter and throw it in the microwave for 30 seconds.
You gonna
No, not actually.
put it on a plate?
Probably should do that.
So you just gonna keep it in there? More like 15 seconds, but...
I think it's melted enough now. Yeah. So, as you can see right here, this butter
Softened butter.
is now the softened butter.
Oh.
So, let's take this softened butter out of its package. Very slimy. It's so slimy!
Take this quick intermission.
So we have two things in the ingredients. We have acids and bases. Acids contain hydrogen, which then they give to bases. The acids that are contained within just this alone is milk, sulfuric acid, niacin, and sodium aluminum phosphate. Then the two bases we have baking soda and iron. Now we only have one neutral thing in this, and it's riboflavin. Next part.
We probably need to think this through.
Go.
Okay, so to begin the mixing process, we're going to be just putting this in a bowl. Basically, the things that's happening when we're mixing this is the advanced stirring speeds up the desolvation of this. Yeah, use scissors.
Get a grown up to do this.
I'm not a grown up. Tasty. Okay. If this is a different color than this, I would probably go to your nearest psychiatrist. You're going to want to leave your trash in a certain area. So basically, once you have all of your stuff ready to be mixed, what you're going to do is you're going to put it in the mixer. So what you're going to want to do is you're going to want to pour your mix into the bowl. And then after that, you're going to want to add your butter and your egg. You need a butter knife for this. Merry Christmas. Then what you're going to want to do...
Nope.
You'll see. What you want to do is you want to basically turn this on and have it moving first before you even start. You have it on one, or well, stir. And you're going to want to put your butter in. Doesn't have to be everything. And you're going to want to put your egg in.
It's fine.
You're going to crack your egg. And you're basically going to wait for that to mix. So basically, while it's stirring, I'm going to talk to y'all about the stirring process and what's happening. So basically what's happening on the stirring is that the stirring speeds up dissolvation. So basically, what's happening? Some of the mixture is dissolving with the egg yolk and the butter because those can technically become liquids, and they're becoming liquids through this. And so it's basically making a new solution, which is a homogeneous, because we wouldn't be able to separate the two. So basically, what's creating right now is a homogeneous mixture. What's happening is, well, one, we gotta speed it up, make sure that it's all good and crisp. Through this, we're going to be making a homogeneous mixture, or something that has no change throughout. The mixing also causes a chemical change to happen here, because as you can see, the otherwise white mixture is actually turned a mild yellow. We want to talk about solute solvent. The solvent would be technically the mix, while the solute is the butter and the egg, because the butter and the egg are there in a smaller quantity. They're actually being mixed into and dissolved in the egg, in the mixture, while the mixture is actually there in greater amounts.
So this pan right here, and now I get to eat it. So we're gonna spray this right here. Not too much, just a little tab.
You want to get all the area though. And what you're looking for when you're mixing is a soft dough. That's what it is. I can't remember the word dough apparently. Push it down. That's what your soft dough should probably look like. If not, after consuming, you may need to go see a doctor. Now that this is more than likely, or mostly clean, you're going to want to just not use this anymore. Yay, removable bowls. Then, when actually making the cookies, you're going to want to spread them out about 2 inches apart. So this is so for the rising process. You want them about 2 inches apart. And you don't want them close to the edge either, because then that'll just be... And after that, you're going to want to place it in the oven. Or after the oven's preheated, even though Cody didn't preheat the oven. Really? That's 350, Cody. There you go. Now, you started your preheating, you just wait for that to happen. And in 2 seconds, we're done. Okay, so basically what's happening is you're going to want to put it in there for 7 to 9 minutes. Isn't it already preheated?
Yeah.
We want to put the cookies in there.
I mean, hang on.
So now that the cookies are placed in there, we're going to want to bake them for around 7 to 9 minutes. So basically, while the cookies are in there for 7 to 9 minutes, the particles inside the oven are, or this is actually during preheat, the particles inside the oven are being sped up, which is causing the temperature to rise to 375 degrees Fahrenheit. When it reaches there, the machine actually stops moving the particles, and keeps it at the same particle speed, which is actually keeping it at the same temperature.
During this process as well, with the temperature rising, the surface area of the cookies are expanding, which in other terms is also thermal expansion. So the matter is changing its shape, its size, and the temperature because of the rise of temperature.
And in baking, this is normally called rising, although this is actually called thermal expansion because the cookies themselves are expanding. And then finally, when they're actually in the oven, going through these changes, the cookies are going through what's called an endothermic change. Basically, they are absorbing the heat until they hit an equilibrium temperature with what's actually inside the oven. So actually, right now they're going through an endothermic change, which is causing the temperature inside and around the cookies to rise and fall depending on what the temperature around them is. So right now, the temperature is rising because the temperature the temperature of the cookies are rising because the temperature around it is actually rising as well, which is causing, which will happen until everything in there is at the 375 degrees that we have set it at.
So once we take out the cookies on out, it is going to be exothermic because the heat within inside the cookie is releasing into the atmosphere, which is room temperature, which is much cooler than what the oven is.
So basically, when it's taken out, the cookies are going through an exothermic change, meaning that they're releasing the temperature, causing the surrounding area of the cookies to rise, which is also what makes it feel hot. It's basically releasing heat until, like Cody said, it was at room temperature.
That's why when you touch something warm, your hand will burn.
Or when you touch something cold, it'll freeze.
And you'll feel it. Because in exothermic temperatures.
What's been happening throughout this project is that the reactivity in these different materials, say the mix, the butter, the egg, the cookies in the oven already mixed together, they're going through different reactions. And these reactions aren't really big, but as shown earlier, the chemical changes are causing a color change, actually, within this. And in the oven, it's making a gas, which it's basically creating a gas around it, which
is a chemical change.
This actually happens the same way thermal expansion does. And so basically, the closer you are to the left side of the periodic table or the alkali metals and the alkali earth metals, the more reactive it's going to be, as well as all the way to the right of it next to the 17th. Okay. And then around the 3rd to the 6th to the 15th, 16th level, the metals and the non-metals that are in that area are actually going to be less reactive than the 1st and 2nd and the 7th. Yeah, the 7th row, or the 7th period.